Hey everybody, I'm Pete. Today we are talking about the single supply logic level converter. Now this is a logic level converter, just like our previous model. But what is nice about this is that it actually has a power circuit involved that can take a V in and step it up to 5 volts, and it can also regulate it down to 3.3. So it can provide both sides of your logic level conversion. And the 3.3 volt side is programmable as well. So let's take a closer look at this and we can talk about all the chips on it. All right, so looking at this guy, basically we've got the power circuit on the top, which involves a step-up circuit. So you can take your input voltage from 3.3 to 5 volts, and then on the output, it will supply 5 volts or 3.3 right here. On the lower section of the board, down here, we've got your actual inputs and your outputs. And this is the TXB0104. And so this actually auto-detects the direction of the data, and you can send data either direction. So it is actually bi-directional. I know our previous logic level converter was named the bi-directional, and this one is named the single supply logic level converter. But in addition to being single supply, it is bi-directional as well. And VCC-A is this side here, A1 through 4. And this is the default setting on that is actually 3.3 volts. On the other side, we've got VCC-B. And this guy, the setting is for 5 volts. And it'll always be 5 volts for this product. And I want to also mention it has a little resistor here at the bottom, and that is actually a programmable resistor. And that allows you to change the voltage conversion level on the VCC-A level. You can do anything from 1.8 volts up to 3.3. So on the hookup guide, there's some various values and what voltages those set to. So you would want to take your iron and actually remove this SMD resistor, and then you can use these other PTH pads to put in a custom resistor there to set your logic level. What I do want to mention that this boost circuit will provide 5 volts and 3.3 no matter what you put into the V in there. So it's really handy if your system is a 3.3 volt system and then you need to talk to a 5 volt sensor. And so now with this single board here, you can use your 3.3 volt system and then it will actually produce the 5 volt side for your sensor that you want to talk to. All right, so we're going to actually show 2 examples today. One where I'm using a breadboard, which is 5 volt logic, talking to a 3.3 volt screen. And that sort of shows how you can come down with this logic level converter. The second example is going to go the other way. So I'm using a 3.3 volt Pro Mini talking to a 5 volt distance sensor. So let's check them out. Yeah, so for the first example, I've got my breadboard right here, my single supply logic level converter here. And then for the example, I'm just showing one of our new 3.3 logic LCD screens. And so I'm using the power directly off the 5 volt line on the breadboard to come into my breadboard. And then I'm actually sending that to the V in on the logic level converter. And my default settings on this are already ready to go. So I have 5 volt logic on this side and 3.3 volt logic on this side. And I'm coming from my digital 7 pin right there, going through the logic level converter and making my way all the way to the RX pin on the screen. So let's plug this thing in and see that she works. And as you can see, the commands are coming through and it's changing the backlight colors from red, green, blue. So there's one more thing I want to share about this example. It highlights the fact that using this ground pin on the VCC-A side is actually pretty important. And so my ground from my 3.3 volt device, the screen in this case, the ground from that is going directly to the VCC-A ground pin right there. Earlier when I was setting this up, I had it grounded somewhere else on the thing, and it actually affects how well the data can transfer because that ground return path goes takes a big loop before it gets back to that TXB chip. So I just want to make sure that when plugging in your ground pin for whatever thing you're trying to talk to, make sure to use the ground pin on that side of the product. So this next example is actually directly from the hookup guide. It shows how to come from a 3.3 volt system up to a 5 volt sensor. So in this example, we're using a 3.3 Pro Mini, And then that is coming to the single supply logic level converter right here. And then this is actually our ultrasonic rangefinder that operates at 5 volts. So you don't want to ever just connect directly from your Pro Mini to this 5-volt thing. It's going to damage your I/O. This guy right here converts that logic level for us. And you can see that we've got VCC wired up through this red here. That's making its way to the V-in. So we're just giving it 3.3. And now on the other side, we've got our 5-volt. And this is going to provide power to the sensor. And then our default settings on this again are ready to rock. So we've got 3.3 volts on VCC-A and 5 volt on VCC-B. This sensor takes an echo pin and a trigger pin. And so those are the lines that we need to convert. So we are coming through A1 and A2, and we make it to the 5-volt side. And then this makes its way up to the sensor. So let's plug this thing in and see if we can sense some items coming close. All right, so this guy is set up to detect distance and will beep a little bit more when things get close. Let's see if we can find this guy. Yep, all right, it's beeping, that's working good. Excellent. What else do I have to check out today? Holy cow, let's see if we can find this. Yep, all right, it can detect extremely large zucchinis. And if you have any recipes to recommend, I would appreciate it. You gotta figure out how to eat this whole thing. So I wanted to share one more thing with this product video. We don't normally do this, but this is actually the production test fixture that was designed for this. And a lot of people don't know that when you design such a small little red board like this, it also takes another rather larger bed like this to actually test it down in production. So our quality control team is working hard to make a custom test fixture for every new product that comes out. So for this guy, we actually just plug in power, and it's a completely standalone system for the production techs. They can put the board down on top of the pogo pins like this, lock it into place, and you just tap this cap sense button, and if you see green LEDs, all is good. So there's a couple examples with our single supply logic level converter. There's plenty more information at the hookup guide, so I recommend checking that out. It'll walk you through both of these examples with clear details. I also wanted to mention that this new single supply logic level converter is really good for high-speed data. Our older logic level converter will sometimes round off your data when you get into really high-speed stuff. So if you need high-speed logic level conversion and want to use a single supply, hit up SparkFun.com and check this out. Logic level conversion needs. I'll say that better next time. That look was like, maybe I shouldn't say that sentence.
I don't know what that means.
The other one is not quite as important, sorry. All right, sorry, I'll look at the camera. I said today earlier too. Anyways, let me try to explain that one more time. Okay.